And in this video we'll be talking about WAN and internet designs. Often network consultants or network architects are provided with business requirements by the customers, and these guys will have to then translate those requirements into network designs and solutions. We've done quite a lot of configurations on the channel in the past. We've configured the routing protocols, we've configured WANs, etc. But in this video, what I wanted to do was bring some of those technologies together and kind of provide an end-to-end connectivity design, right? So that you get an understanding of how each of those protocols come together, how each of those technologies come together to provide connectivity for a particular use case. Alright, so let's talk a little bit about this particular topology which we have. So let's say we have a customer, let's call him, I don't know, maybe Stark Industries, right? And so we've got this customer, and what they're doing is, for starters, they have a headquarters here in Bangalore. All right, and they also have what we call as regional centers in, say, Singapore and Tokyo. So predominantly, let's say this particular customer is based out of Asia, right? So they have regional centers in Singapore, Tokyo, and a headquarters in Bangalore. Initially, when they came up with the network, they did not foresee that they are going to expand geographically. So they designed it in such a way that they did not have an individual ISP or an internet service provider at each of these regional centers, right? So that's why you see there is only WAN connectivity between the sites, but there is no internet provider. So the internet traffic is backhauled to this particular headquarters, and from there we are going to use the internet service providers to go to the internet, right? That's how it was designed. In addition to that, you can see at each of those sites, so in each of these regional centers, they also have branch offices, right? This is again a very typical design, right? So different cities in Singapore is going to have various branches, and they are all going to be aggregated at this particular regional aggregation point. It could even be a co-location, right? Similar is the case with Tokyo, and also with even in the case of the Bangalore headquarters, they seem to have few branches across Bangalore, and they're getting aggregated in either in the main branch in Bangalore or maybe a co-location in Bangalore, right? So this is pretty straightforward. The main thing to understand here is that this was the current design, but now what they want to do is they want to expand, right? So that's why you see they are trying to expand to other continents, right? So they are moving, they want to add more regional sites in Europe and US. Great. And while they're doing this design, now they intend to add a local breakout in each of those regional centers, because they are foreseeing that sending all that internet traffic back to this Bangalore headquarters might not be a good idea, right? You are going to saturate the link. So they are adding a local capacity, local ISPs at each of these sites. Okay, so that's the initial understanding of this topology. Let's also speak for a few minutes on the links, right, which are connecting each of these sites. So you can see there is between Singapore and Tokyo, you have like a 10 gig link, another 10 gig link over here. This is just 100 Mbps. So you can look at the thickness of the line. So whenever it is more thick, it basically means that it is 10 gig or 1 gig, whereas this one is just 100 Mbps. Similar is the case. You have 1 gig and 100 Mbps over here, right? So these are the WAN connectivity. You can, for this example, we are not restricting to a particular WAN. It can be any type of WAN, right? Let's just, for our simplicity, let's just assume it to be a particular, it's just any type of WAN, right, which is connecting each of these sites. Okay, so that's about the link capacity between each of the sites. Okay, next, let me just clear the screen. So now on the left hand side, you can see I have, or the customer has given us those layman requirements, right, in terms of the routing policies that they intend to have. So let's start from the top. You see there is a WAN related policies, and they also have internet policies, right? Because between any of the two sites here, you see two types of transports. One is the WAN transport, and the other one is the internet service provider. So they have given us two types of policies which they want us to design, right? First thing is they want us to tag properly the corporate and the internet routes, right? So the corporate routes are anything which are originated by the enterprise, right? So any of the routes coming out of Singapore, anything coming out of Tokyo, etc. Those are the routes. And the internet routes are maybe generally it's like the default routes which are coming in from the ISPs, right? Generally ISPs, when you pair with, you just import the default routes, because you don't really have a need to import the whole routing table of the internet, right? So you just take the default route. But then the requirement here is that you need to figure out a way to tag them properly. Tag the corporate routes versus tagging the internet routes. Next is the Tokyo should always use a faster link. What does that mean? From the Tokyo side, we should always prefer this link, either for outbound traffic or inbound traffic, right? We can use the 100 Mbps as a backup link, whereas use the 10 gig link as the primary one. Europe and USA should talk via the headquarters. It means that this particular site and this particular site, the direct communication should prefer this particular path, right? It can use this one, but use this as a standby, right? But use this as a primary because this is like a 1 gig link, okay? And also they are telling us to propose a load sharing design for future use cases, right? In case if you want to do load sharing between these two paths, how would we do it, right? They're asking us to propose a design for that as well. And the last thing is they don't want the Tokyo office to be able to talk to the US office, right? Maybe because of some kind of say, maybe one of the site is doing some R&D work, or maybe it has some critical information, some server farm, they don't want the communication to happen, so they are asking us to restrict it, okay? So that's all about the WAN policies. Whereas coming to the internet policies, they are asking us to, every internet exit will use NAT, which means what is the internet exit? This is the internet exit, this one, and this one. So all these 4 internet exits should use NAT, right? That's understood, because you normally use private addresses inside the inside your AS, and you would want to translate the traffic as it is exiting into a public address. So that's why you're going to use NAT. The headquarters should set up ISP1 as the primary. So this one should be primary, right? Because you have 2 ISPs here, and this one should be the secondary or standby, right? That's how they want it. Singapore and Tokyo will continue using the headquarters for internet, right? So the traffic from here is going to come down here and it's going to go to the internet. They were doing it even now, they want to continue doing that in future as well, right? For these 2 sites, maybe they are not foreseeing that too much of internet traffic is going to be originated. That's why they want to continue using Bangalore as the internet exit for them. And if that fails, right, so when we clear the screen, they're also telling that if headquarter links fail, so if these guys fail, then they are asking us to route that traffic to Europe, right, and use this breakout, right? And they're telling us that if Europe also fails, if this is also down, then they're asking us to where? Route it to US, right? So in this particular case, they're asking us to send it here and then send it out like this. So that's the order. First prefer headquarters, second prefer Europe, third prefer US, right? That's the policy. And the last policy is for, what's the last policy? Sorry, let's get rid of that. The last policy is Europe and USA will have a local breakout. So Europe and USA should use the local, internet breakouts, right? And should use each other as backup, which means that if say from Europe, if this guy fails, then the traffic from here should be sent here, and this particular link should be used, right? Similar is the case for US. And they're telling us that if that also fails, say US link is also down, then you need to send the traffic to the headquarters and use the ISP from here, right? So that's the final policy, right? So I think the requirements are pretty clear, right? They are very crisp and clear, very nicely explained in the layman terms. Now we need to translate this into our design. At this moment, if you want, you can probably take few minutes, right? Pause the video and then probably think of how you would solve this problem before I get to you in the next few minutes, where I will give you like a one way of solving this, or one version of a solution. That might not be the best, that might not be the most optimal one, but it's just one version, one way of doing it, right? All right, so we're back. So these are the steps which I've highlighted, right? So these are the serial steps which we will follow to solve this. For starters, right, let's start from step number 1, which is deciding which routing protocol we are going to use, right? So which routing protocol are we going to use here? It's gonna be BGP, right? That's actually pretty clear, because why BGP? Because you've got a lot of IGP islands, correct? Which is a protocol which is always used to kind of connect the various IGP islands. You can see OSPF, EIGRP and all of that. So when you have islands of this sort, the best protocol to kind of connect these guys, right, is the BGP protocol, right? And the other thing is, from a policies perspective, you saw the policies are pretty crystal clear, but to implement these policies, it would be a little bit of a complicated task, with a lot of route filtering and all of that if you're using, say, something like OSPF or AHRP, right? But in case of BGP, it gives you the flexibility of using policies, right? So because of that, we are going to go with BGP for this one, correct? And the other interesting reason is also because, I mean, if you look at it, right, if you look at this design, you have ISPs, right? And whenever you're peering with the ISP, you always use BGP, right? When I say ISP, I mean the internet service provider, right? And if you're already using BGP at one particular part in your network over here, why not use BGP at rest places as well, right? That way you have less things to manage, less protocols to manage. From a configuration perspective also, it becomes much easier. Okay, so many reasons, like I said, scale and policies and reusability of the protocol, since you're already using it internet, that's the reason why you're using BGP. Okay, let's get rid of that. So if you're using BGP, the very next question people are going to ask you is what are the AS numbers which we are going to use or which we are going to design, right? Now let's start with the headquarters. At the headquarters, you can see I've gone and used the ASN of a public ASN 12345. The reason is because in this case of headquarters, you can see it is clearly connected to two ISPs here, right? When you're connecting two ISPs, right, it is a very it's a given that you have to use what we call as a provider independent address space, right? It means that we have to do a bit of admin work, which is we need to go down to a regional registry, go and get the address space, go and get the AS number from them, right? And once you have that address space, you can advertise it through both the ISPs, right? So because we are not reusing the address space, or we are not obtaining the address space, we are not using provided address space, right? That's why we are using public ASN over here, right? Whereas it's quite different in, let's say, in this particular case, right, we are using private AS here. Why? Because in this case, as you see, it's connected to only one ISP, right? So in this case, it's pretty simple. I don't have to really run behind the registry and get a address space for myself. I can just buy the address space from the internet service provider themselves, right? So they are going to give me an address space, and I will obviously use it inside. I'll configure it on my routers. And then I'll obviously use a private address space, private AS in that case, and the ISP will do the job of advertising that network into the internet, right? That particular, because ISP owns that address space, so it will do the job of advertising it into internet. So in this case, I can just go with private AS number, whereas in case of headquarters, I have to use a public ASN, because I will be peering with two different ISPs, right? So that is the reason. Similar is the case here as well, using private. There is no internet service providers here, but still we are going with two unique private addresses, because we want each of our sites to have unique identifiers, which we can later use for, say, community strings, and we can easily segregate the traffic by using certain policies, right? There's nothing wrong in, say, using one AS number, say 65,001 at all the 4 regional centers, but doing this makes it much more cleaner from a policy perspective, from a consistency perspective. Alright, before we move to the next one, there's one last thing I'll cover here is, you might ask what is happening with these branches, right? So with the branches, we are technically, we don't really need to run BGP over there on the branch routers, right? So we can just use IGP, like in this case, this site is using OSPF. So I can just use OSPF on these routers, right? So I can use OSPF, and then I can just send a default route, right? I can send a default route here, so that these branch routers will send all their traffic to this aggregation point. So I don't really need BGP on the branch, any branch for that matter. This branch here as well. At all the sites there is branches, you don't really need BGP on them. We are going to use just IGPs, right? So so that's another interesting piece. Okay, so let's wrap the next 3 points very quickly, right? So we're talking about BGP here, which is so when you're talking about BGP, mainly BGP connectivity, basically we want to talk about the BGP sessions and BGP communities, right? So what type of BGP sessions are going to be there? It's you already know that between 2 different ASs we always use eBGP. So say between Singapore and Tokyo, it's going to be eBGP. Here as well you're going to use eBGP and so on, whereas inside the AS we are going to use iBGP, right? So So we're going to use IBGP. Right now, when you talk about IBGP, it's going to get a little more interesting because, for example, headquarters, right, is a site which is probably going to have a lot of other networks as well. Maybe they have a data center, maybe they have a campus, right? So in that case, there might be quite a lot of core routers. And if the number of core routers is probably say more than 4 or 5, then it makes sense to not do a full mesh of IBGP sessions, rather do something like a route reflector, right? Something of this sort, right? Because you can go back and check my channel. There's a very detailed video on route reflector design, but long story short, route reflectors help you to reduce the number of IBGP sessions. So that's a fair design to use at the headquarters. Whereas if you look at the other sites, you might have just maybe 1 or 2 edge routers, in which case you can just run direct IBGP between them. You don't really need like a route reflectors at those sites. Okay, so we now know where we are going to run eBGP. We also know where we are going to run IBGP, and in case of IBGP, we'll also run route reflectors in the headquarters. Next is communities. So what's the whole concept of communities, right? So communities is again very interesting, and actually I think that will help us solve one of the important problems from the customer. The customer is asking us to kind of tag the routes, right, as a corporate or internet routes. So here is one site where I've kind of highlighted this design. So what we are going to do here is all the routes which are originated by 65003, right, this particular AS, we're going to tag it. So communities are just a way, they're just strings, they're just a way to tag the routes, right, so that at a later stage you can then kind of configure some policies based on these tags, right? And we'll actually see an example of doing that. But at this point, what we are doing is we are just tagging it, right? So I've just shown it at one site, the example, but doesn't mean that it's only at this site. You have to do it actually at all the sites. But the idea here is you can see what the format what we are using is, we are using the public AS of this particular customer, which is 1, 2, 3, 4, 5, followed by colon, and then we are using the private AS of this from where the routes are originated. So every route which is sent out, we are going to tag it. Similar is the case for ISPs, right? From the ISPs, we are going to get what? Default routes. So that also we can tag it, like we are going to tag it with ISP's AS number :0, right? So when you get different default routes from different ISPs, we will be able to kind of differentiate using these tags, right? So that's how we are solving the first problem, which is tagging corporate or enterprise routes versus internet routes. We are doing that using communities, right? The configuration will have to go on at all the sites so that you are ready to implement the policies in the next stage. All right, so let's come to the routing policy here. So we've done already that. We'll come to this section, right? So we need to make Tokyo prefer this faster link. Now without a policy in place, right, what happens? If you don't have any BGP policy, you don't have any issue between Tokyo and Singapore. It will always use this 10 gig link because that's a direct link, right? So BGP will always prefer the shortest AS path. Problem happens between headquarters and Tokyo. Between headquarters and Tokyo, always they'll prefer this shorter link, but we don't want that link to be used because it is a weaker link or it has low bandwidth. So we need to put a policy here. So we can do in two ways, right? Either put a policy here or put a policy here, right? So option number 1 is where what we're gonna do is the Tokyo routes, right, which are getting learned, right? The Tokyo routes the Tokyo routes are sent in both the directions, right? So the routes which are sent to Singapore and they are going to come into my headquarters, right? Those routes I'm going to increase the AS value to 200. Because I'm increasing the AS value to 200, those routes will be preferred when compared to the routes coming directly from Tokyo, right? Because those routes are preferred, what will be the traffic path? You should always remember that the routing updates and the traffic path is always in the opposite direction. Because I'm preferring this routing update, the traffic path out of headquarters will be in this direction. As a result, traffic is going to go in the 10 gig link, right? So what we have done with this, the outgoing from headquarters we have taken care, right? Now next is we need to also take care of the traffic which comes into headquarters. How would we do that? So as of now, the traffic which comes into headquarters is coming in this direction. Why? Because the headquarters sent its routing updates in this direction and this direction, but the routes which came in this direction were preferred because it has the shortest path, right? What we will do is, when we are sending the routes in this direction, we will poison the route. How would we do it? We will do a AS path prepend, right? You know the logic of AS path prepend, where we take the AS number and prepend it twice or thrice, so that we deliberately increase the AS path. So when Tokyo sees the route coming in this direction and this direction, it will not prefer this one. Why? Because this has a longer AS path, right? So in that case, what Tokyo will do, it will prefer this. As a result, traffic which is sent out of Tokyo will come in this direction. So as a result, traffic entering headquarters will come in this direction, right? So we have taken care of both traffic coming out of Tokyo and traffic coming into Tokyo by putting this policy on the headquarters. The same thing can also be done by putting the policy on the Tokyo router as well. Pick the headquarter routes which are coming in this direction, right, which are coming from Singapore. So coming from the Singapore pier, we are going to increase the AS local AS value, right? Because of that, between the routes coming in the direct path versus this path, this will be preferred, right? And the opposite direction, right, for the incoming traffic, what we are going to do is the routes which are advertised directly along this path, we are going to do AS path prepend, right? By doing that, what we are doing, because you're doing AS path prepend over here, the headquarters will start preferring the routes coming from here, right? So it will send the traffic in this direction, right? So basically it's the same thing what we did earlier. It's just you can either do it at this point or this point. Preferably I would do it at the headquarters, because it's always nice to do all your routing policies in a centralized place, right? Rather having dispersed at different places. So that's just a recommendation, but yeah, technically you can do it at either of the edge. And how we are doing it? By tinkering with the path attributes and preferring a particular link over the other. And that's another the beauty of BGP. That's why we chose BGP. Okay, coming to the next problem, which is we want the Europe and USA sites to prefer the headquarters, right? While talking. So let's come to that over here, and let's grab my pen. So we've got Europe and USA. As of now, because they have a direct link here, whenever they have to talk to each other, they will prefer this, right? eBGP, shortest path, AS path, this is going to be preferred. Now how to implement our policy? Again, pretty simple, how we did earlier, right? So what we are going to do is, we are going to, when the routes are sent, right, when the Europe routes are sent along this direction, we are going to poison them, right? We are going to poison them by doing AS path prepend. So the routes which are coming in this direction, we'll prepend it with say 2 times of this particular AS number 65003, right? So when that route reaches here, maybe twice or thrice, right, any number of times, and when the route reaches USA will see that it is receiving the same route in this direction and this direction, but this particular route has the shorter AS path, right? Because it has not been poisoned. So it will prefer this one. Because it is preferring this route, what will be the outgoing traffic? It will prefer this link, right? As a result, we have implemented the policy. So now USA will talk to Europe along this link and not along the direct. Same thing you have to do in the reverse direction. You have to do the same poisoning work in this direction as well, right? So here also you use this 2 times of this particular AS number. So when the routes are sent out of USA, poison them, so that ultimately what will happen is that Europe will receive that route along this link and it will start preferring this one. So both the sides, we have implemented the policy which is needed. Now the next thing is, they're also telling us propose a load sharing. What is load sharing? Load sharing basically is, they're telling us that, look, we also want you to give us a design where probably half of the traffic will use this link and the rest half will use this link, right? Similarly in the other direction as well. How would we do this? Now load sharing is again something which probably you can't do it exact 50%, right? to the dot, but you can do it in an approximate way. That's what we are doing here. What you could do is, in the previous use case, what we did was we prepended all the local routes towards USA, right? We did the AS path prepend of all the routes originating from this AS. But this time, what you can do instead is prepend only 50% of the local routes, right? So prepend only 50% of the local routes. So what will happen because of that? Because of that, the routes which have been prepended, so let's just for example, let's assume we have 100 routes here, right? So again, this is just a rough example. It won't be exactly 100 routes. So that's why I said it's very difficult to, even if you exactly had 100 routes, you can't really predict which of those routes you're going to have traffic originated from, right? So maybe there are a few clients which will not talk at all over a day, so you can't really load share exactly to 50%. So but for example, I'm going to take, let's say you had 100 routes, I'm going to take 50 routes, another 50 routes, right? So these 50 routes, what I'm going to do is I'm going to do AS path prepend, just like how I did earlier, right? Because I've done AS path prepend, this particular path will not be preferred, this particular path will be preferred, right? Because it is going to be the shortest AS path. But for the rest of the 50 routes for which I did not do AS path prepend, this particular path will be preferred, correct? So that's a way of doing load sharing, and you'll have to do that on both the sides. That way what happens is 50% of the prefixes, when they are emitting traffic, it is going to use this link, and 50%, the rest of the 50% of the local prefixes, traffic will be sent in this direction. Same for this guy as well, and we would have implemented the load sharing scenario which we intend, right? So it's almost the same, both of these use cases, only slight difference. When you're doing AS path prepending, here you prepended all the local routes, but here the difference is that you prepended only 50% of the local routes, right, towards each of the peers. Okay, and the last WAN policy which we want, just delete that, is Tokyo should not be able to talk to USA, right? So how do we do that? Remember, we did this whole communities, right? Now we are going to actually use them. So I had, like I mentioned earlier, I had used just the community values only from one side, but I had also told you that we'll be using the same thing. I've represented it only at one side, but we'll actually be using them throughout. Now, so as a result of that, we can now implement this policy, right? What I can do is, on this particular, so we know that how is the eBGP set up here. We know that there is a, my pens. We know that there is a eBGP here, then we have a eBGP here, right? So when the routes are basically learned at Tokyo, right, what we can do is we can implement this policy. We're going to say drop all the routes which are matching the community value of what? 123456 colon 65,004, right? So all the routes which are originated from here will have the tag of 65,004, correct? Because of the community value. So we can drop them here. Same is the case with this guy. So we are going to drop all the routes 65,002. So all the routes originated from Tokyo will get dropped here. If you don't have routing updates in your RIP, you will not be able to send traffic to that particular destination, correct? So now what we have done is, using the simple approach of community strings, we were able to tag the traffic, and then at the other side we were able to match with that tag and drop the routes concerning that particular community, right? So that's a great use case of how community strings are really helpful for us to design our policies. Okay, so next let's come to the internet policies. So when you're doing internet policies, the first thing is, every internet exit will use NAT, nothing very fancy over there. It's just a configuration piece. So yeah, we don't have to spend much time there. Coming to the next, before coming to that piece, let's actually also kind of look at what I'll highlight here. I think we discussed this before, but we are using the provider independent address space here at the headquarters, because we are using two separate ISPs like I mentioned earlier, and we're using provider assigned address space here at the regional sites, right? Because we are using one single ISP at each of these. Okay, so that's something which I wanted to highlight. Next. Okay, now coming to the actual policy, like I mentioned here, our requirement is that the headquarters should use ISP1 as a primary or active, whereas the ISP2 as standby, right? How do we do this? So to do this, again, we have BGP also the other important thing which I've highlighted is using IPGP, right? Always make sure that when you have a design of this sort where you have like two edge routers, right, connecting to two different ISPs, make sure you run IPGP between them, because that will give you a fallback situation. If one of your ISP is down, traffic will be sent through the other ISP, right? Make sure you always run IPGP between them. But to implement this policy, again, pretty straightforward. What we can do is, you can do again in different ways, but what we'll do is we'll do it on the router which is connecting to the ISP2. We'll implement this policy, right? What is the policy? We'll say that the AS path should be prepended, right? Because you know that we have a provider independent prefix, right? It can be anything. It can be something like say 192.1 dot maybe 10.0, right, /24. Let's say this is our provider independent prefix. We went to the registry, we got this IP prefix, and we have obtained our public AS number, and we are advertising it to both the ISPs. So when you are advertising to both the ISPs, what is the policy we need to put on this particular router? We need to put the AS path prepend towards ISP2. We need to AS path increase. We have to poison this particular route, or we have to poison this particular path, right? So by doing that, what will happen is that we'll always prefer this particular router, right? Because we sent we sent the poisoned route in the outbound direction. So when the traffic is coming from the internet, right, this particular path will be preferred because it has the lower AS path, right? So that's how we are preferring one ISP over the other for the incoming traffic, right? Now for the outgoing traffic, you always use path attributes something like local pref. And so again, the idea here is, let me just get rid of that. Local pref, remember the default value is 100, right? So the routes which are coming from the internet, right? So basically the default routes which are coming from the internet will have by default, it will have a local pref of 100, right? So on this path, you will have 100. But what we are doing is, we are adding a route policy here to change the local pref to 90, right? By doing that, what will happen inside our network, this particular path will be preferred. As a result, the outgoing traffic will go in this direction, correct? So by tinkering the AS path and the local pref, what we were able to do, by tinkering the AS path, we were able to influence the incoming traffic by using ISP1, and by changing the local pref value of 90, we were able to influence the outgoing traffic, right? And we have implemented this policy, which is using headquarters as the ISP1 as the primary. Okay, so this one is done. All right, so the last let's come to the last diagram here, I think. Yeah, so using this diagram, we'll just cover both of the last two policies which our customer has given us, which is this one and this one, right? Just to read through what we intend to do. Singapore and Tokyo will use headquarters for internet, right? Singapore and Tokyo is not shown in this diagram, but assume it is there on the top here. And we know that Singapore and Tokyo don't have local internet breakouts, right? They don't have local ISPs, so they are going to use headquarters, for their internet connectivity. But if headquarters fail, right? I explained this earlier. If headquarters fail, they want to use Europe. If Europe fails, then they want to use US, right, for the internet connectivity, right? That is either this link or this link. That's the failback scenario, right? And the last policy is that Europe should always use the local. Europe should use the local breakout. If this fails, then maybe it should use the US internet. If this also fails, then it should send the traffic to the headquarters and go in this direction. That's what we need to implement. Now to do this, this might sound very complicated, but actually to do this, it's pretty simple. And we are going to do this using just tinkering, using a bit of community, using communities, using default routes, and using local preference. How do we do this? Okay, so how do we do this? Things to remember. What are the facts here? The facts is at every ISP, right? So generally, again, the assumption here is that every ISP is just giving us a default route, right? So at every ISP we are getting a default route. So we're getting a default route in this direction, we're getting here, we're getting here, and we're getting here, right? So the default routes are coming into our system, right? This default route is coming into Europe, this one into US, and the default routes in this direction are coming into Bangalore, right? Once the default routes are coming into our BGP, then we are running eBGP everywhere, right? So those default routes which are coming from one site are getting then distributed or being sent to the other places, right? So at any point of time, if you see in Bangalore, we are going to have how many default routes? We are going to have 3 default routes. The ones coming from either ISP1 or ISP2. In this case, you're going to have default routes from ISP1, ISP2, and you're going to have the default routes which have entered through Europe, right? And which is coming inside, right? Same way the default routes which are coming in through the ISP4, right, will also enter or will also be redistributed back into the BGP, and it will enter the headquarters, right? So if you look at the headquarters alone, you can see these are all the default routes which are coming in, right? So the orange one, green one, and the pink ones. Between the pink ones, what we can do is, remember, we have already put a policy in place to prefer the default route coming from the ISP1, right? If you haven't put that policy, you can put a new policy, and you can put a local pref of 200 and 100, right? I think in the previous example we put 190 respective of it, right? The same logic. So between ISP1 and 2, we are preferring ISP1 by this way, right? And then what? Between Europe and US, we want to prefer Europe. So that's why the local pref value is a little higher, 90, whereas the value here is 80, right? So by doing this, what we have done is the headquarters now will, in its BGP's table, it will get default route from ISP1, right? Will be preferred. If ISP1 is down, then it will use ISP2. If ISP2 is down, then it will use Europe, or if that is also down, then it will use USA, right? And since Singapore and Tokyo are just connected to headquarters, right? Singapore and Tokyo are using the internet from the headquarters. The same logic, or the same, they are going to get the same, same default routes over there as well, right? Because they are just sitting here, correct? Singapore is here, Tokyo is here, right? And they are connected in this way. So the same default routes are going to enter them as well. So they are also going to follow the same order. ISP1, ISP2, Europe, USA, and that kind of satisfies our first rule. Okay. Now what about the second rule, which is for the Europe and US? So here again, what we'll do is we will put a policy in place where the default route coming from the local ISP3 is going to be giving a local pref of 100, whereas the one which is coming from USA is going to be given a local pref of 90, and the one coming from headquarters is given a local pref of 80. Same logic here as well. 100 for local ISP, 90 for coming from Europe, right? And 80 coming from the headquarters. By doing this, what we are doing here, we'll end up preferring local, then USA, then headquarters. Same thing here as well, right? And why is this policy going to be very easy to configure? Because we already have tagged. Remember, we have put the community value in place, correct? If you go back to maybe my slide, let me just go back. If I have a diagram, yeah, there you go, right? So we have a diagram here. So here, remember, the routes coming from the ISP also, we have tagged them, right, using the communities. So it's very easy. When you define the policy, it's very simple. All you have to do is you have to for this particular community value, routes coming from that particular routes with that particular community tag, we are going to assign the local pref of so and so value, right? So you have this community value everywhere, right? Over here, over here, over here, as well as over here, all the 4 places, right? So it's very easy. All the 4 default routes coming in all the 4 directions is going to have a community value, and as a result of that, using those community values, what you can do is you can put a policy quickly in place telling to assign the right local pref values, and ultimately influence which local route or which default route will be preferred at each of the site. And by that, what we have done is we have implemented this policy as well, right? We were able to, at Europe, you were able to prefer this guy, then prefer this guy, and then prefer this guy. right? So that's mainly what I wanted to cover in this one, right? We went through a very common scenario of a WAN and internet connectivity for a particular customer, right? We looked at why we use BGP, some of the BGP granular details, and then we looked at how you can implement certain WAN routing policies and internet routing policies, right? Hope that was useful, and do come back for more videos. Thanks a lot for watching, and